determine whether the following lines are equal, parallel but not equal, skew or intersecting. So we have two lines, so I have written here so that we can visualize better. So first line is just 1 plus t, negative 1 plus t. So from this line we can see the direction vector b, but let's say b1 direction vector is just 1, 3, negative 1. And from the second line we can find direction vector, let's say v2, that's the 2, 1, 4. Okay, and we know that if these vectors are parallel, that means if one is constant multiple of another, I mean v2 is like 2 times first or 3 times first, or v1 is like 5 times second or negative 2 times second, etc. If these two lines are, if these two vectors are parallel, then the lines are parallel. But clearly we have negative 1, this is all positive, so v2 is not constant multiple of v1, or v1 is not. So these vectors are not parallel. That means these lines are not equal and they are not parallel as well. Now we check if they intersect. If these two lines intersect, then they will be intersecting and we will be able to find a point of intersection. If they do not intersect, since they are not parallel, they will be skew lines. Okay, since v1 direction vector of first line and direction vector of second line are not parallel, the lines are not parallel, not equal, so they are either skew or intersecting, are not parallel, and obviously not the same, not equal. Now let's try to find a point of intersection between these two lines. If we are able to find a point of intersection, then the lines will be intersecting. If we cannot find a point of intersection, then we call them skew. Okay, for we said these two equals, look at the first, x equals 1 plus t, here 1 plus s. Okay, so that is, now set them equal because the x, so 1 plus t equals 0 plus 2s. Similarly, y equals y, negative 1 plus 3t equals 1 plus s. Okay, then we'll take care of the third components later, third equations. Okay, solve these for t and s. Okay, now there are several ways you can use the method of elimination, a method of substitution, etc. Okay, so from the first, what I'm going to do here is let's solve this for t, plug that in the second equation. So from here this implies t equals, subtract 1 from both sides, 2s minus 1, substitute in the second, then negative 1 plus 3t, t is 2s minus 1, okay, equals 1 plus s, only one variable, so we should be able to isolate s. Okay, that's negative 1 plus distribute 6s minus 3 equals 1 plus s. Numbers on the right side, the variable in the left hand side, so we can subtract here, negative 1 minus 3, negative 4, so add 4 both sides. Okay, then we get 6s minus 1, so 5s equals 5. So that gives s equals 5 divided by 5, 1. Okay, then plug this into here. So t is, now we can find t from here. Okay, so t is equal to 2 times s minus 1, so 2 times s minus 1, 1. So we found t and s both 1, 1. Now we want to see if this point satisfies the third equation. So we had the third equation here, look at here. That is from the third, 4 minus t. If this is true, negative 3 plus 4s with our ts values, okay? Is this true? That is, let's see, plug in 1 for t, 1 for s. So 1 here, 4 minus 1, 3 is 3 equal to, plug in 1, negative 3 plus 4 times 1, 4. Negative 3 plus 4 is 1. 3 equals 1? No, that's false. Okay, that means there is not a common point. So the lines are not parallel, at the same time they do not intersect, skew. Okay, final.